Hello everybody, welcome to this week's video. The objective for today is going to continue building up from those sounds that we put inside of our engines in week one. In specific, we're going to work on specialization, trying to measure and create behaviors to understand where a sound is coming from and an audio source is, how it is behaving within the scene. Then we're going to touch on attenuations, the use of attenuation curves and filters that you can use utilizing the same patterns. Then we're going to go into profiling and how to measure or understand the behaviors of our sound sources within the engine from Wwise. And then finally, we're going to check how to trigger an audio file or an event utilizing the engine and Wwise. So that's going to be our process for today. We're going to start with trying to review the process on where we were last week. So within our Unreal scene, we just did a couple of changes. We did a couple of implementations of a game component, and we observed how we could play a sound utilizing either blueprints, so the blueprints, the global blueprints that existed here, and we also put this event on our map, and we utilize the post event. So when we run the game, we can hear. Oh, sorry, I think I turned it off. Yeah, auto post. So that when we go into the game, we can hear our object in the scene. Perfect. So from here, we are going to touch on the multiple things that we are going to do for today. So first thing that we're going to do in our Wwise project is apply an attenuation curve. An attenuation curve is going to measure our the changes that we can apply to an audio source configuration in reference to a distance. So in the closest that you are to the object, the sound is going to play with the original configuration, and then we can create changes in a specific, in attenuations is how what volume changes over a distance. So we're going to touch on that configuration and see, well, first of all, how to do that, because that will help us create sources that sound much more realistic. The farther away that we are from there, the least that we can hear from them. And we're going to start with that. So we're going to jump into our Wwise scene where we left it. First, we're going to go into the designer layout, and from here we have, of course, our audio that we had input last time. There are a couple of changes that I want to do. So first of all, if I hear it, and when we were playing around with it last class, I don't think that the volume was like necessarily the greatest, so I'm going to raise the volume a little bit. I'm going to put it in 10. That is a lot better than what we need. The second thing is that because this is a continuous sound that is going to be playing while I'm in the scene, I'm also going to enable a loop here at the bottom right that is going to continue playing the sound. But because it is going to be looping over time, even though the sound is pretty, well, is more than a minute long, I also need to check how it plays with itself. So when the sound ends, how it goes back to the beginning as part of the loop. For that, we're going to do a little bit of a fade in, fade out. I'm going to check how it sounds here at the end. And you see that there's like a small click there because the transition is not necessarily too solid. So I'm going to cut here at the end when it starts to fade out. I'm going to do a really tiny fade in. Let me control and use my wheel to make that fairly small. Perfect. And then we still can hear the click, but I can look for a moment in the sound wave where we have something similar, a bit of an uptick. So I could cut that point in the beginning and put it like around here. You can see how that sounds. So that sounds pretty good, but we still have the problem that it is the clip is no longer there, but we can definitely hear it going back to 0 and going back again. So I'm going to make these fading a lot shorter so that it feels part of the configuration. I'm going to do the same thing here, make it a little bit smaller. that feels a little bit better. We're in theory not going to be listening to it a lot more, but the clipping is no longer there, and we can probably hear the whole sound and then come back to it, and that's not going to be a problem. Perfect. Now that my sound is ready, I'm going to start managing the attenuation. So how do we do attenuation? Well, there are a couple of ways that we can manage that. The one that I'm going to do right now has to do with the specific configuration of the sound. I'm going to go here in my right pane, and I'm going to click on all. In here, we are going to see all of the different things that you can configure for this audio source. In specific, the one that I'm looking for is this positioning one. Because I know that that's where it is. I don't necessarily have to keep there. I'm just going to click here on positioning because it's where I'm going to find it. But you could just go to all and look for it. But in positioning, I'm going to here check for attenuation. You'll see that an attenuation is enabled, but there is no configuration, no attenuation made. That's the first thing that we're going to do. We're going to create a new attenuation. I'm going to put it a name. Let's name this box attenuation. Perfect. And we are going to create a new one inside of our default work unit. Now you'll see that we have this new pane that appears here at the bottom, and that is going to be the configuration of the box attenuation. This window is a little uncomfortable for me because everything is like down here, and we're going to be playing a lot with it right now. So I'm going to go back to contents on this space, and I'm going to double click on our box attenuation so that we can go to the full panel. Now, as you can see here on the left pane, when I jump into the box attenuation, it went into a different tab. I went from the audio tab, in which I had the digital horror sound, into the share sets tab that contains the box attenuation. Both are fine for us to try to access them. There's also these two tabs here at the top that we can try to navigate between them. The effect is the same. But now I have this curve, this graph that says it measures volume and then distance. So the maximum volume, which is 0, we're actually tracking descent, is going to be when there is no distance between the object and the user. And then the lowest amount of volume is with the maximum distance. In this case, that is 100. Now, this value is going to change a little bit. I'm going to set it as 2 different numbers because both engines, Unity and Unreal, are going to use different measurements. So if you see this number change a little bit as the tutorials move on, is because the measurements for Unreal are going to be in centimeters and the measurements in Unity are going to be in meters. The difference is going to be in a matter of 100. If you check this and the graphic measures that we will do in a moment, the difference is are values in reference of 100. So a measurement of 10 in Unity will be a measurement of 1,000 in Unreal. Disclaimer. So that's where we are going to move forward from. How does the attenuation curve work? Well, we can actually play the sound and check it out. So I'm listening now to the sound, and if I click here on our graph and I start to go farther away, I can hear the difference that it's going to have or as distance increases. With the object closer to 0 being a lot louder than when it is closer to 1,000 in this moment. Now, next thing that we can try to do is that maybe this progression that is very linear is not the one that you're looking for. We can right click on the curve and change the way that that curve is made. We can see that we can make it like an exponential curve that will make the louder sound a lot more present and then have a more drastic drop on the tail end. We can make it an S curve, which is going to have like a little bit of a sustain and then drop and then stay lower. We can also do a logarithmic curve that is going to have like a larger drop and then go back to 0 like it was a slide. So we still have some noise over here. But that's it. That's honestly all that we need to do. I'm going to leave it here in the logarithmic curve. I think that this is pretty good. I'm going to go back into my digital horror sound, and now we can see that the box attenuation is configured here and the distance scaling is perfect. So that's that. I'm going to save, go into my sound banks, then generate checked, make sure that everything is generated and good. You see that it is pulsating and generating again, and then that's that. So now the next thing is going to be jumping into the engine and checking how this works. So first things first, we're gonna, from the engine, try to check how that change sounds. I haven't made no changes, I just generated the soundbox in Wwise. If I play here, you'll see that first of all, we don't hear the sound anymore. And if I get closer, we can hear it. And then when I move farther away, here we go. Pretty good. So we can hear the changes there. That's pretty neat. Now, the next thing that we would like to do would be to try to check what is the affected area. In this moment, because we are utilizing the AK event to try to post our object utilizing the AK ambient sound, we can see here that an area, a trigger area appears. This area is going to be our attenuation curve area. Now, this is a little bit of, I guess not like a trick, but it is important to remember that this is the actual actionable area, but that also means that in the outer edges, you're closer to zero in what our attenuation graph is going to be. So if I'm looking at my attenuation graph and I'm looking at these distances of 1000, that means that these, the like very, very outer edge, let me select it again, is going to be 1000. In this case, that is 10 meters because we are measuring everything in centimeters. By the way, if you want to try to have a closer experience to what it is, I would still recommend it, but you can jump into your project settings and then go down into your editor appearance. In here, if you go into the advanced selection, you can change the values from distance from centimeters into meters. This is going to be really useful to have it here. However, it will not generate a change in Wwise. Wwise is still going to recognize centimeters as the measurement for Unreal. So if you change it or not, that doesn't matter that much. What I would say is that you should select here in show searchable names as show by default. This would allow you to, oh, did I not save that? Did it not change? This would allow you to see what those measurements are in your editor, and that becomes fairly important. Yeah, no, I did. Interesting. Okay. So now, next thing that we will do. Oh, I just did it for the grease. Okay, I'll change that in a little bit. Okay. So next thing that we would like to do here has to do with the specifics of Unreal and how new audio is being produced. As I mentioned last class, we can utilize we can utilize the global blueprint, but that becomes very ineffectual. We need something that can be replicated relatively fast, a system similarly to that seen in Unity that allows us to just have a component that we can add together. In those options, utilizing these AK ambient and AK events objects becomes really useful. I could grab, for example, my cube here, grab my play digital sound and add it into my cube, and then when I move my cube, I am moving it to attach together to that AK ambient object, and having that sound attached to that. Let me reset this. 0, 0, 0. That way, something at the center of it. That way, the configuration of the cube can be can just have the object attached. That being said, not always you're going to be utilizing the post event as your main reference for, well, posting the object. We need to create a system that can be replicated towards and or play a different configuration for that sound. And for that, we're gonna have two different options. So first thing that I'm gonna do is I'm gonna delete that AK ambient object. I'm also gonna grab this cube and move it into a folder. I'm gonna move it into the Wwise tutorial objects just so that it's easier to organize. And then I'm gonna copy it. Let me make a new object. So I have 2 cubes here, and we're gonna use each of them for a different experiment. So this first one, the one that we're gonna put here on the left, is going to be the one that we're gonna turn into a script, and this right one is going to be the one that we're gonna attach things towards. So 2 things that we can do. First of all, select the object. If I go here into the top left, I can transform this actor into a reusable blueprint class that can have a script behavior. This is going to be really useful if you have one object that is going to turn kind of like a prefab, that it's going to have the same configuration, and you can utilize scripts to modify it specifically. I'm going to select that, make it into the new class, and I'm going to name it cube speaker. Let's select that. That is going to open into a new blueprint object that we can utilize to change that configuration. So we see here that it's an object, that it has an AK game object because I attached that to it last week. That may become important in this case. And then aside from that, it also has an event graph that we can utilize for changing the nodes. So, and now that we have this reference, we can add to this on event begin play our post event configuration. And then in this post event configuration, let's say that I'm just trying to play the digital horror, and that from where I'm replaying it, I am trying to find the reference to the actor that has this object, which is going to be our reference to self. Get a reference to self. So the cube is going to play the object. I'm gonna compile that, save that, and let's see if that works. Let's play. And we have that sound. We move away, it stops, move back in, it sounds. Perfect. Now, here at the right, I'm gonna do a little bit of a different configuration. Instead of creating a new object that, again, this creates an actual object blueprint class that I would need to come in and create back again. Instead of doing that, I'm gonna create a blueprint that is going to be added as a different object. So I'm gonna go back into my content drawer, then create a blueprint class. So in here we can either make an actor blueprint that is going to be useful, but for my case, I'm just going to use an actor component because I'm going to place these blueprint into other actors. I'm going to make this, let's say, let's do like audio player. So it's just going to be our thing that made for that, and we're going to double click it. Perfect. Let me save that. And from here, we're just going to make it like, again, a really simple configuration, but this is really useful for us as we try to create like a skeleton that we can build our project around. So same thing at the gameplay, I'm going to post the event. Now, the question is, what am I posting? Well, in here, we're going to start messing around with variables. I'm going to go into the variable space and I'm going to look for an AK event. I'm going to look for it in the audio event, look for an object reference, and then whatever this is that we're gonna change the name to an AK event ref. I'm gonna drag it in, I'm gonna click get AK event ref, and I'm gonna connect the AK event there. And now we need to find an actor. The actor is going to be whatever is contained in this space. For that, I'm just going to look for the actor and then change the reference so it can be an actor object reference, same thing, get actor. Now these variables right now are just serving us to try to populate where is this sound going to be played and what is the sound that we're trying to play. Why is this fairly important? Well, because we want to make this an iteratable program. We want to be able to put this object wherever, and that the object event reference and what is playing the object changes depending on what is contained in this script. But in theory, this will allow us to just have a player and just attach it to wherever we want to place our sounds. So for last week's example, in theory, instead of putting the AK ambience, we could have done something like this. And these would allow us to have like a flexible system that we can just attach the references to. However, for that to happen, I need to make sure that I click here and make our variables public. That way I can populate them from within the scene. So So I have my audio player. Let me go back into my scene, and I have here my second square. What I'm gonna do is go into the content browser, grab my audio player, and I'm gonna drag it into my cube. Now, if I play this right now, it will of course not work, at least not yet, because I haven't populated the variables. So I'm gonna click on the audio player, and inside here you will see that we have an AK event reference and the actor. So what is the event reference? I can just click here and select our pulsating breath. And what is the actor? The actor is the cube that I'm containing the variable from within. So I'm gonna once select here and drag and drop our cube so that we have it on display. Now, if I play this, I should be able to walk to my cube and have the same configuration. Perfect. This is really, really good. Now, there is one more thing that I wanted to select. If you do this player, you'll see that even if I select the player, there is no visualization of the configuration of the game object. Like, neither of these objects, at least not in the way that I'm distributing them, are doing the same thing that just dragging and dropping. Let me go into Wwise Audio, Events, Default Work Unit. Like, if I select this is the only way that I'm seeing the attenuation sphere that I'm going to be utilizing as reference. So if you wanted to use one of these configurations to try to see if this works, I would recommend you to do the same thing, drag and drop the object, restart, drag and drop one of the event configurations, put them, set them as 0, and check that the distance is working correctly as you want. Make that in Wwise bigger or smaller, whatever way you need to, and then once you're done, you can just delete that object to not have redundancy in them. That being said, once again, these are different options to do the same thing. You can use one of the 3 methods interchangeably depending on what you use for. I would say that this method is really useful to have multiple things that you're trying to just put sounds really, really fast. Dragging and dropping the events is good as long as you're being precise about what that object is. And then finally, being able to do the blueprint inside of the object is good as long as you have multiple things that you're attaching to the actor, because that will create interactivity in spaces that may not be or may not have it before that. Now, the last thing that I want to say about the attenuation curves and the spheres is that if you find that even looking at the curve in something like that is kind of a little bit obtuse, another option that you have, let me put this inside of the cube and restart the measurements one more time. One thing that you can do to try to make this a little bit more visually understandable is click here on the layout of all viewpoints. This will show us the scene view from different perspectives. What I'm gonna do is I'm gonna go into here, the one at the top. Actually, let's make them a little bit bigger. In which we're going to see the top view of them. In this configuration, you can see more or less all of the objects in the scene and what is being touched by that attenuation curve as long as we have them. You can also click on your middle mouse button and make a line. And this is going to measure in centimeters more or less what the distance is. So if you have 2 objects that you're like, oh, I know that I want this sound to reach that space, you can use this tool to have a measurement and then utilize that measurement to inform your attenuation curve configuration here when you have them in Unity. Okay. Now that we have a usable attenuation curve, we are going to change the values that utilize that attenuation curve so that we can add or increase the characterization, I guess that you could say, of those audio sources that we're putting within our scene. The first thing that we're going to do is we're going to add a low-pass filter. A low-pass filter, as we mentioned in class, is going to allow for higher frequencies to be cut off from the audio source the farther away that you are from the distance, because as we mentioned in class, lower frequencies travel a larger distance than higher frequencies. So we're gonna jump into our into Wwise, and we're gonna add a low pass filter configuration to our attenuation curves. Within Wise, it's going to be really simple. We can do this from a couple of times. If you go into audio and, well, let me first change the layouts. We could go to our audio and then down here, we could select attenuation and do all of the configurations from here. However, the thing that I'm going to do is I'm going to go into my share sets and then double click on the box attenuation so that we can see it here on front. I'm going to select the low pass filter. You'll see that nothing appears on screen, and then I'm going to change it to custom. In custom, we're going to see it, first of all, that it's added. If we select control, select the volume, we'll see both of them working at the same time. And if I play the sound, we'll see how it changes over time, over distance, the same way that the volume one does. If we put it here, for example, it's a little difficult, but you can hear how the frequencies that are still present are basically only the lower ones, which are the ones that are being allowed by the low pass filter. We can make this a little bit more noticeable. I'm going to change this to, let's say, an exponential curve, so that that cut here feels a lot more easy to hear. We can also do that by, for example, turning off the volume settings. And if I just select the low pass filter, let me stop the sound one more time. Custom, and then no pass filter, and then the low pass filter, which is going to be custom. Yeah, there we go. We can hear these changes a lot more noticeably. How here, for example, only the lower frequencies are present, while here we see more of that whoosh on top. This filter, of course, let me pause it. This filter, of course, is filtering things in a percentage. At 0 distance, none of the frequencies are filtered, and the closer that you are to the max distance, the more frequencies are going to be filtered. That means that at 80% of the distance, only 20% of the frequencies, the lower 20% of the frequencies, are passing through. That means that by the time that we get to 100, you can only hear like the whisper of the lower frequencies. They are technically not changing in volume, but when we get to 100, no extra frequencies are passing through. We could make it then so that the last point changes a little bit, so that we always have a presence of lower frequencies, but they should be, I would say that at least cutting it at 80 is the lowest that I would go down. So that like by the maximum distance, when we are closer and closer to silence, the presence is like only the lowest of the frequencies. We're gonna add the curve for volume one more time, and then we'll see how it sounds. Yeah, you can still hear a lot of the lower frequencies even though you're farther away, and that's the effect that we're looking for. Let's save, go back to our layouts, generate checked. Let's see how that sounds on engine. So the way that it will look in Unreal, let me just go back to the main view. Well, both of these kind of overlaps, so actually we should delete one of them. We don't count. Let's just put this farther away on the other side. Cool. I'm gonna delete them soon, but I will actually, yeah, let's delete the cube speaker. We can create it again as an object, but for now let's just leave this one there that has the audio player. So now we can check if the attenuation curve is working as intended. Let me jump into the scene. Let's walk to the cube. So we can hear that change, that more frequencies are present the closer that we are to the cube. However, if we want to make that a little bit more apparent, we could go into our attenuation settings, and let's say that I'm turning off the volume one so that I only listen to the low pass filter. Let's put that, let's set that like 80. That way all the frequencies will never be cut out, but at least like 80% of them will. Let me save this, go into my sound bank layout, generate checked, and then let's see what happens. I play this. Immediately, for example, you can hear very low frequencies that we couldn't a little bit earlier. If I walk closer, you'll see the frequencies slowly start to appear until we have that full soundscape. So now that we know that it is working, I'm gonna reactivate those filters. Let me put this back into custom with the same generate checked. So the next thing that we're going to cover is cone attenuation. Cone attenuation is going to allow our source to behave a little closer to our sources, because we make sounds again around us, but we are not an omnidirectional source. We are not making the same volume of sound in all of the different directions. That directionality allows us to listen a lot more directly if we're talking in front of us than it would be if a person was listening to us while they are behind us. So by adding a cone attenuation, we can try to put a lot of that directionality within the configuration of our sources, and it's going to allow for sounds to be heard in the way that you expect them to, more, well, like you would, I guess. So the only thing that I need to do to create cone attenuation is going in here inside of my designer layout back to the attenuation configuration. Once again, I can do that by, like, for example, double clicking on my box attenuation configuration. From within here, you'll see here at the bottom right that we have a cone preview attenuation mode. I can access cone use, and this will make available an extra sort of configuration that will allow me to get the cone attenuation and value that orientation that we were talking about. If I play here, you'll see that I have an extra control that allows me to select not only how it is measuring distance with the outer edges of that circle, but also how it works in that initial cone that is directly in front, that is being affected by directly my source, and then on the sides, and then on the back. I can modify that attenuation by a cone max attenuation. I think that this by default is in -8. Which is the amount that is reduced, but I'm putting it on -12 so that, oh my god, so that it can be a little more readable. We can also affect how that outer edge, like how much of that sound is being affected by the direct distance, and then how much of that extra that is still listenable, but it's not going to be as attenuated, affects. So we can hear how that sound changes. For example, over here we have not that much of a change in distance, but we already hear the changes in sound. As in here, it's still direct and pretty loud. Here is significantly less loud, and here is a lot less loud. All of that in the max attenuation, which would be here at the outer edge, would be affected by the max cone attenuation. I'm just gonna close those angles a little bit so that they are a little bit more recognizable inside of our engine. Now let's just stop this, go to my sound banks, generate checked. So now in our engine, we can observe this object, and it's going to behave the same way that we expect. Now there's one more thing, which is the fact that I am pretty sure that we can check for the coordinates on how this behavior is going to happen following our cone configuration. If we look at the directions that are part of our object, with the red one being probably what the front is going to be, and then the sides behaving differently. So I'm gonna play and see if that is correct. Perfect, so we hear here if the behavior is the same that we had heard before, but if we go to the sides, we see that there is a massive drop in distance, even if we're really close to the object. With it being really, really low here on the side, and here we can hear the change based on the cone attenuation. All right, fantastic. So next thing that I want to discuss is a couple of acknowledgements in relation to Wwise. The first one has to do with how sources are configured and how the audio files we are putting in those audio sources are being utilized. As we mentioned before, most of the time when we are jumping into Wwise, we're going to be adding either mono or stereo files into our audio sources. But in this particular case, or if for any stereo files, we're going to continue hearing those files only as mono, as long as this 3D specialization is the same. So let me turn this up so that we can go here. I'm gonna go into positioning. Okay. So we have enabled our 3D, our listener relative routing, but the 3D specialization is only made in based on our position. If we set this in position and orientation, or we turn it off, we're going to be listening to the file as it comes in, basically as a stereo signal. But that stereo signal is going to be behaving as mono value in the sense that it's going to be sending things at the same. If I play this sound here, you're going to see how the behavior of both of these lines is going to go higher, in the sense they're going to be different, but if I turn it back into position, you'll see how they equalize and become the same behavior. If I value it for position and orientation, it's going to simplify it itself a little bit, but it's going to allow me to pan or value the 3D mix so that if it is into 0, we're going to have more of that 3D imagery, 3D information, the fact that these two channels are different into the mix, and the closer that it is to 100, the more that they're going to be equalized into themselves. Now, of course, a position information is the thing that allows us to hear more from one direction to the other, but they are going to be one direction or to the other, assuming that the source is coming from the same location. Because of computing needs, unless you plan to take advantage of the fact that both of those channels are giving different information, I would recommend you to keep the position as is. But if not, the position and orientation value is there, and you can utilize the 3D mix to benefit as much as you want from that information. Now, the second thing that I want to try to add on to has to do with the emitter configuration. You'll see here at the bottom that we have an additional 3D position value. If you wanted to, you could select here an emitter position automation. We can edit that, and it's going to give us an extra window. We saw a little bit of an example about this window in class, but it's going to allow us to change how the emitter relates to space. Especially in relation to the player's position. So let's add another, a couple of points. Let's add like 3. Let's make this second one here at the left. Let's make this third one here at the right. This will then, every time that I play the source, give me a different point from which the sound is sounding. Let me make that a little bit more relevant. Because you can barely hear it there. Is it because of the distance? Interesting. What's happening here? Is it because the attenuation curve is made there? Yeah, there we go. Let me change the values one more time. Yeah. So every time that we select a new one, we see that it's playing a different point. You can add all of these emission configurations, and if we save them and put them into our sound bank, they are going to follow that requisite. So every time they're going to play one of these 3 in sequence. We can change that. Instead of being a sequence, select it at random, and then instead of selecting one after the other, is going to put them in any random selection. We can also change the value so that instead of being just one point, we can change or add multiple other points to that same travel. So let's say that we have like this big circle, it goes from one to the other, and if I play this one, you'll hear how that sound is going farther away and coming back. Let me make that more apparent by turning off the attenuation. So I'm gonna put this in none. Yeah. We can hear how it is like traveling around. We can hear it like going all around. Now, that option is there, but it should be said that it will depend on like what they're using it for. If you have like, I don't know, a pigeon or something, like a different source that is going to need for you to plan the different positions that they're coming from, or you're going for a vibe that has a source that can be placed in multiple spaces. So let's say that you're putting birds on trees and you don't want them to always come from the same space, so you change the position values a little bit. All of those things are going to be very beneficial from this system. In our current examples, I'm just going to leave them as is. The emitter is going to stay in position, and we're going to reactivate our attenuation. Let's go to the box attenuation. All of these values, very relevant, really important tools for you to try to have, and are there for you to utilize if you need them. The next thing that we're going to take a look is the profiler. The profiler is going to be our stepping point to make sure that everything that we're putting inside of our Wwise project works exactly as we need to. It's relatively simple, but it is a connection that allows Unity and Wwise to work together to try to measure what events or what systems that are being introduced through Wwise are working in every given scene every time that it plays. And configuring it is fairly easy. As we mentioned before, a lot of the things that a lot of the problems that arise from doing or utilizing this sort of software is the idea that like maybe things are not working the way that you want them to. So the profiler is a really good tool to try to see specifically what is working and what isn't and why. So let's check now how we can connect that and how this is going to work. So first of all, from our layout, we're going to change from the soundbank layout to the profiler layout. You can do that by clicking here from the layouts or pressing F6. Here we see 3 panes differently that are going to help us try to track how the behavior of our project is making. How do we connect the project? We see here at the top that it says that it is not connected. We can click here on the top when it says connect to remote platform, and when we click that, we'll see that a new window appears that is offering us all of the connection points that are going to be part of this routing process. I can select here and click on connect, at the middle, and it says that the auto inversion is made. We have an error on voice starvation, but in principle, I think that it should work out. Now, we do this so that then we can press the player here and be able to have it. It is worth noting, because of licensing issues, there is a chance that when I click here on play, it will break out. Oh, it didn't. But we see here that the Wwise program, as it is appearing here, is directly reacting to the behavior that I'm putting on the screen. I'm gonna do a couple of turn around here. Please make it loud. Go it back again. Okay, I'm gonna stop. And when I stop, you see a couple of behavior extra things. So first of all, I'm going to go here and stop the capture. And let's see what we got. So first things first, we got an event trigger here on the side. We can also have that the action trigger, we watch the play event, is here on the center. What is playing it, and the moment that it is stopped, when I stopped rendering the game, when I press stop on the game. We see that we can check this over a period of time, when it was sounding and when it wasn't. So before I started playing the game, there was no sounds, and then when I started playing the game, there was a sound there that was present, and I can check how much was the player listening at any given time. We can check that here at the top visually. It shows us like in a stereo configuration how much energy was being processed. We can also see that in the output peak values here at the bottom, we have like moments of silence and the moments when they were actually being received by the output. All of this is really useful information. It's going to become more apparent later in the line. Part of the importance of the profiler is that we can utilize this window to try to debug our setup and see where connections are light. For example, we can see here that our event is being placed it is playing, and how much is being listened, and what is the object that is receiving that play event. In our case in particular, that is going to be the pulsating breathe event that already exists there. We can also change into the voices part that tells us what the specific game object is. In our case is that Camphor Cube 2, which is the copy of the cube that we already had. That's really, really good. Now, The last thing that I want to mention here is that we can also see how much of the CPU is being used by these values, and that is going to become really relevant right now because this is a lot of what we're checking for. If we are utilizing much more CPU than the one that is allocated to us as the people that are trying to handling sound, we need to try to deload a lot of the extra sounds that are present in our scene. And that is the next thing that I want to try to work on. As you probably already could tell, the sounds that we're going to be playing with are still the sounds that we are playing with are still playing even when we are not like listening to them, and we need to try to change that. The ideal scenario would be to try to create a system that deloads all of the sounds that are not going to be listened to or perceived by the player at any given position in any given time. So how do we do that? Well, it's relatively simple. The thing that we're going to do is, well, first of all, jump into our Unreal project. And actually, I think that now let's just use this. So the easiest way to try to do this is through a trigger sphere. Basically, it's creating a sphere that occupies the same distance as our attenuation curve, so that when the player is no longer within that attenuation curve, we can stop hearing that. Just for visualization purposes, I'm going to go ahead and grab this event. I'm gonna put it into the scene. That way we can have like a visual reference of what the attenuation curve is. I'm gonna raise that later, but it is just going to be there for reference. So this is as big as what my attenuation curve is, and the idea here will be for me to be able to stop playing the sound when the player is no longer here, and start playing it back when the player is inside of this area, so that the attenuation curve works in tandem. How are we gonna do it? Well, first things first, I'm going to open a new window. Let's make this a little bit bigger. I'm gonna go into Windows and I'm going to look for the Place Actors browser. That Place Actors browser is going to allow me to look for whatever type of object I have. Like I could look for a cube, and it would allow me to find that and drag it into the scene. That's really useful. But in this moment, the thing that I'm looking for is a trigger volume. It could be a trigger sphere, but the trigger volume, well, actually no, let's do a trigger sphere. The trigger sphere, that trigger sphere is going to live inside of our cube. Let me restart the sizing again. Okay, so that is our trigger sphere. Now, it is not seeable because its radius is really small, so let me make that radius big. Let's make this 100. Cool, so now we have that. That trigger sphere is viewable, but we have also the attenuation sphere that we were looking at in a little bit earlier. Let me make this window back small. Perfect. So the attenuation sphere is this big, this really big yellow circle, and the trigger sphere is this small. So we need to make it a little bit big. I'm gonna not make it as big as I want. I know that the measurement for the trigger volume, because it's the configuration that we have in our Wwise project, sorry, is going to be 1,000, right? So I can make it half of that, and that's going to be where the example is going to live. Why am I making it 1,000 and not bigger? Well, 500 and not bigger, because I want to make the example very apparent. So we're gonna put it very, very within the attenuation sphere, so that we can hear like a cutoff, and we can see that the system works before we continue with that. Great. So now the next thing that I'm gonna do is I'm gonna change our play system a little bit. Let's go back to our content and let's open our audio player. Perfect. So here we have our audio player. Again, this would work the same if we were doing or using a cube speaker. Actually, there is an argument that it would be better for me to do this with the cube speaker. I'm gonna let me grab the cube speaker and utilize that as our reference. Again, I'm doing that because I want to keep this system, like the audio player, as straightforward as possible. It's just going to be add the sound and add where it plays. This other configuration, even though it will work, it's very specific to the thing that I'm trying to make. So I'm gonna not have it for what I need, but for the other thing. I'm gonna drag the cube speaker into our folder, and then I'm gonna drag the trigger sphere into that cube sphere. And then I'm gonna do the same with the other one. Do we delete this cube? Let's make it not visible. Yeah. I'm gonna restart the sizing on all the other things. Oh, the sizing, not sorry, the transform position. Great. So that I can have the same values but on the other side. Fantastic. And then I think that I want to deactivate this. Well, it's the same system. I'm just gonna erase it for now. It's gonna be deleted. Great. So one more time, we have this object that can be edited inside of a blue plane. I'm gonna close that. It has the post event. The post event is going to be associated with the play circus and the sound, and then it's targeting itself. I'm gonna delete the post event, and we're gonna play around with that trigger volume that we talked about. How are we doing that? Well, first of all, it's the same thing. We have the trigger volume and the trigger sphere, sorry, and we can utilize the reference of the trigger sphere to change a configuration. We could use it to do the same post event, and that is actually the same thing that we're gonna do. I could get the reference into our level editor, but instead I'm gonna do it inside of our cube sphere. So I'm gonna go into the variables and I'm gonna look for another, let's say that this is the trigger sphere, and that trigger sphere is going to be another type of variable. Let's look for a trigger sphere object reference. Perfect. I'm gonna make that public because I do need to have that option. Get trigger sphere, and then that reference of that trigger sphere is what we're gonna use to check the event. Now, sorry, I'm gonna delete that because what I need is another node, another trigger node. So I'm gonna go into my trigger sphere, and here at the bottom, after I have selected the variable, you see that there are a bunch of events that can happen in relation to the activity of the trigger sphere in particular. What I'm looking for is on actor begin overlap. What is this going to do? It is going to tell me, hey, what is when this happens, I want something to happen. So when an on actor begin overlap, I'm going to look for a post event and then connect the rest of the variables as we had them before. So where am I playing this here, and what am I playing? I'm playing the sound. Perfect. Great. So now I compile this and this should work. Let's check it out. It didn't work because I haven't fed the trigger sphere into the variables. So trigger sphere is going to be the trigger sphere. Perfect. I selected my cube speaker, and in here I found the variable that I still needed to fill. So now, whoa, we can hear it. Now the problem is that after I have left it, I can hear it now continuously. That is not ideal. So the next thing that we need to do is to try to change the configuration of the trigger sphere so that something also happens when I leave. What's the problem? That I don't have the event for the other things. So the first part is easy. I just select the trigger sphere, and then on actor end overlap, I do the other example, right? So Control C, Control B, and I just select this. What's the problem? That I would just be playing the event again when this happens. So what I need to do is go into Wwise and create a new event for these graphics. So I'm gonna right click and create a new event. Is this the audio? Yes. Create a new event, and I'm gonna create a stop event And that stop event is going to now exist here. I have the play, the sound, and the stop the sound. I'm gonna go into my sound banks, my sound bank layout. I'm gonna drag my stop event. You can see both of them here now. Generate checked. Perfect. Both events should be present. And now if I go here and I recompile and save and load my assets through the Wwise browser, we should be able to see them both. Yes, here is the UA asset missing, so I can reconcile the real asset that creates the asset, and then from that I can feed it into my cube speaker. So in here, into my post event, I hear now that we have a stop event, and this should work. So let's try it out. So very out of nowhere, we should hear it, and then it's off. The best way to try to see, if this is working as intended is through the profiler. So let's look at the profiler and see what we get. We go into the profiler. Let's remake the connection, reconnect to private mode. And then let's go to Unreal. Let's make this small so we can see. Okay, so no initial signs on the side there. If I jump in, we see that the event is triggered. And then when we leave, we see that the action is triggered again and that the event stops and finishes. And we can do that multiple times. Fantastic. Great. Now, a couple of last things that we need to try to do here will be to make these a more believable source. So I am going to go ahead and change the trigger sphere's diameter. As I mentioned before, we know that the trigger sphere is that the attenuation sphere is 1,000 centimeters. So we're gonna make that a little bit bigger and make it 1100. That way, if we check the other one, we see that the trigger sphere is slightly outside the attenuation sphere. I'm gonna change that configuration one more time. Let's do it not 1100 but 1050. Make that closer. The trigger sphere is still outside, and that should work pretty well. I'm gonna now delete that sphere that we were utilizing just for referencing, and here is my sound. I hope that this was enjoyable. By next week, I'm gonna change the flooring a little bit so that we have more space. I'm gonna remove some of the objects that we have so that we can continue messing around with this. But yeah, this is where I'm gonna leave it for this week, I think. Now, this is all that I wanted to have for this week. Please, if you have any questions, one more time, make sure to communicate with me. Send me an email if you need to. And I'll see you next week. Thank you so much.